Okay, so we have another first order linear equation differential example here. In this case, we're going to find the particular solution to this differential equation, 3x y prime minus y equals the natural log of x plus 1 for all x that are greater than 0. And this needs to satisfy an initial condition, right? So that when x is equal to 1, my y value or my output is 2. So when we see those words particular or we have an initial condition, we know this is what we might call an initial value problem. Okay? So it's particular. We have this initial condition. So we're going to run through the same steps we've done before. We're going to find the standard form for this equation. Then we'll determine v so that we can multiply by v. And then finally we'll integrate. So putting it into standard form, I'm going to divide everything by 3x. And so that gives me y prime minus 1 over 3xy equals, and we're just going to combine all of the right-hand side and put that over a 3x. So what we can see here is that my p of x is negative 1 over 3x, and my q of x is ln x plus 1, all divided by 3x. So this is going to allow me now to determine my integrating factor. My integrating factor is v of x. And remember, v of x is defined as e to the integral of p. So first thing I'm going to do is figure out what my integral of p of x is, because that's going to go up here into my exponent. So I'm dealing with negative 1/3 the integral of 1 over x dx, which is negative 1/3 natural log of the absolute value of x. And so here, we'll go ahead and use that power rule, property of logarithms, and I'll put that negative 1/3. So this is equal to what we have up in the exponent. V of x is e to the natural log of x to the negative 1/3, which those cancel, and we're going to get that v of x equals x to the negative 1/3. And so we can drop those absolute value bars because it doesn't have to be positive now that it is not in the argument of a logarithm. And simplifying, we could just say v of x equals 1 over the cube root of x. All right, so we've got our v value right here. And then we have our standard form first order linear differential equation up at the top. So what we're going to do now is we're going to multiply that equation by our v of x value that we just found, our integrating factor. So what I had up above, y prime minus 1 over 3x, y equals the natural log of x plus 1 over 3x. And I take all of that and I multiply it by x to the negative 1/3, which is the same as what we have there. It's just a matter of preference how you want to write it. You want to feel comfortable at this point switching between the rational exponent and the cube root, and then using those negative exponents to move things to other sides of the fraction. So what this gives me is x to the negative 1/3 y prime minus x to the negative 1/3 times 1 over 3x y equals x to the negative 1/3 ln of x plus 1 over 3x. So on the left side of the equation here, now we have the reverse of the product rule. And so if you were to take the derivative of this guy, you would end up with that guy. And since we know that x to the negative 1/3 would give me the derivative here, we can now say on our left side, well, this is the same as d dx of the product of the x function and y. So that would be x to the negative 1/3 y. And that's going to be equal to, I'm going to simplify over here, and that's going to become 1/3. I've got the natural log of x plus 1, and then x to the negative 1/3, and then that x is going to give me x to the 4/3 in the denominator here. All right. So at this point, we're going to integrate both sides, which gives me that x to the negative 1/3 y equals 1/3 the integral of the natural log of x plus 1 over x to the 4/3 dx. So in order for us to integrate this, we're going to integrate by parts. I'm going to skip to the next sheet here so I've got more space. We're going to start with x to the negative 1/3 y. I'm just rewriting what we have. 1/3 of the integral ln x plus 1 over x to the 4/3. All right, so first thing I'll do, and I'm not going to write this the whole time, I'm just going to carry that down to the bottom. It'll save us some space as this becomes larger. I have 1/3 the integral of natural log of x over x to the 4/3 plus the integral of 1 over x to the 4/3 dx. And of course, all of that needs to be multiplied by the 1/3, so I'll put some square braces there. So in order for me to integrate this first piece, I'll do a little scratch work here. This is the same as saying the integral of x to the 4/3 negative 4/3 ln x dx. All right, and in order for us to do that, we'll do our integration by parts. So liate, I'm going to choose u to be ln x, so that means u prime is 1 over x. Then v prime is x to the negative 4/3. Integrating that to get v, I end up with negative 3x to the negative 1/3. So this piece of my integral is going to become uv. So I've got 3x to the negative 1/3 ln x minus the integral of uv prime, which is 1 over x times negative 3x to the negative 1/3 dx. So that is negative 3x to the negative 1/3 ln x. That's plus 3 of this integral. And this x and this x become x to the negative 4/3. Which gives us, for this first piece that we're integrating here, I end up with 3, and the integral of x to the negative 4/3 using our power rule is going to be negative 3x to the negative 1/3. And we know that because we already did this piece right there up here. All right, so that's my first piece. That, what I've calculated there, just represents this first piece of our integral. We still need to integrate this. So doing this second piece here, I'm going to scroll down and do that. That's the integral of x to the 4/3 negative power. And my power rule in that situation lets me know that I'm going to get negative 3x to the negative 1/3 again. So going back up to what we have above, I have this 1/3. I'm going to write my answer that I've gotten here in red, and then my answer in purple here. So I'm going to bring that v and y down that we had. I have x to the negative 1/3 y equals, I have the 1/3 here. And I've got negative 3x to the negative 1/3 ln x minus 9x to the negative 1/3. And that would be plus that other integral that I did in my scratch work, negative 3x to the negative 1/3. All of that, and then we have plus our arbitrary constant c. So cleaning this up a little bit and distributing that 1/3, I've got this is equal to negative x to the negative 1/3, natural log of x. The 1/3 times the minus 9 will give me minus 3x to the negative 1/3, and the 1/3 times the negative 3 gives me minus x to the negative 1/3 plus c. So you'll notice here that all my terms on the right have an x to the negative 1/3. I'm going to factor that out as a GCF. So I've got negative x to the negative 1/3. Pulling that out leaves me with natural log of x plus 3 plus 1 plus my c value. And so doing that, I have natural log of x plus 4 plus c. So now I'm going to divide everything, both sides of my equation, by x to the negative 1/3. And what this does, this simplifies. Now I have y equals negative the natural log of x plus 4 plus c over x to the negative 1/3. So this is my general solution here. But of course, we were given an initial value in this problem such a long time ago when we started. So what we're going to do now in order to solve the initial value problem and find the specific solution, we're going to use the initial value to determine what c is. So we're going to use that y of 1 equals negative 2 to determine c. So what we have here is negative 2 equals negative the natural log of 1 plus 4 plus c over 1 to the negative 1/3. Which, simplifying that, the natural log of 1 is 0, so I've got negative 2 equals negative 4 plus c, and we end up with c equals positive 2. So my particular solution in this situation, we're going to have y equals negative the natural log of x plus 4 plus 2 over x to the negative 1/3 power. And that's our final answer here, but because I'm out of space on my page, I can't scroll down anymore, I'm just going to erase it and rewrite it a little bit more cleaned up. If you want to rewind and look at what I had, that's fine, but I might write my answer more like this. So the particular solution to this initial value differential equation problem is that y equals 2x to the 1/3 minus the natural log of x minus 4.